Let us return to the Costanza and colleagues 2017 paper for a moment. Suppose the authors search the literature for the best available value estimates of ecosystem services and add these estimates to obtain the worth of a square kilometer of coral reef or mangrove forest. Table 4 shows several ways to combine these estimates. The paper on which I focus next uses the basic value transfer aggregation method of assuming constant values within ecosystem types. Costanza et al. 1997 provided an estimate of the global value of ecosystem service by multiplying their best estimates with the size of these ecosystems. Their estimate valued the total ecosystem services between 16 and $56 trillion. The midpoint was about twice the value of global man-made GDP. Apart from showing that it is big, even relative to man-made GDP, some questioned the use of this estimate and argued that it is only a severe underestimate of infinity. In my opinion, much of the value of this exercise is in combination with the replication nearly 20 years later, when Costanza and colleagues repeated this exercise with new estimates for the value of these ecosystem services. The total worth of nature was about 3 times larger than before. However, this increase in the value was only due to ecosystem services being more valuable than previously thought. And when we consider changes to the natural environment using the new estimates for ecosystem services, then we have lost some $20 trillion of these services. In the meantime, the global man-made economy had increased by nearly 40 trillion. Obviously, these two figures are nearly meaningless to compare, since the loss of natural capital affects many billions, while most of the increase in man-made capital is enjoyed by only a few. So far, we have investigated value estimates for specific natural resources or ecosystem services. And as pointed out by Núñez and Van den Berg 2001 on page 206, much of the literature on the economic valuation of biodiversity is actually about the value of biological resources and is linked only tenuously to the value of diversity. By contrast, Weizmann considers the valuation of diversity explicitly. In a paper called the Noahs Ark problem, he asks how best to preserve diversity with a limited budget. Weizmann argues that Noah's ranking R for species I can be thought of as the expected marginal distinctiveness plus utility per dollar, where delta P captures the increased survival probability from a project at cost C. UI captures the direct utility of species I existence, which can vary by species. Since most of us like panda ants better than mosquitoes, and DI is the diversity value, which is the focus of Weizmann's paper. It quickly becomes beyond my level of mathematical fluency, yet the intuition here is that species may be considered more or less distinct from others, let's say in terms of their position in a phylogenetic tree. And talking about phylogenetic trees, the panda ant, by the way, not an ant, but a flightless wasp. Weizmann later applied this idea to the conservation of cranes, where he relied on expert opinion for input to the different survival probabilities and phylogenetic tree distances of the crane family. Weizmann's analysis suggests that counterintuitively, the analytical preservationist favors making the safe species safer at the expense of making the endangered species more endangered, because a whole line may therefore be made safer. Continuing the seeming paradox, other things being equal, the strength of this effect is greater when there is a longer time horizon or a lower discount rate. While I think this thought exercise by Weitzman was useful. For example, it helped me formulate an interpretation of my map with expected extinction rates. I doubt its value for conservation policy. I have seen several critiques that the ranking ignores ecological importance of keystone species or ecological services of niche species, and it ignores interdependencies such as with pollinators or between predator and prey. As a final thought in relation to the valuation of nature more generally, let me quote Krautkramer once more, who opens here with the quote from Söderbaum: attempts to measure the taste of consumers or willingness to pay in actual or hypothetical markets are not very productive if those tastes or values and corresponding lifestyles are unsustainable in the sense that they systematically contribute to a degraded environment. Since individual preferences play a fundamental role in neoclassical economics, the role of consumer sovereignty in social decision-making is an area of disagreement between ecological economics and neoclassical economics that's unlikely to be resolved. Today, we looked into the valuation of nature and ecosystem services. We first explored the benchmark for weak sustainability with Hoteling's rule. Hoteling's analysis suggests that extraction follows a path such that resource prices minus marginal extraction costs increase at a rate equal to the interest rate. Strong sustainability considerations and fairness goals likely give a slower resource extraction path. Next, we looked into various methods of providing value estimates for nature, such as hedonic pricing and contingent valuation. We have reviewed literature on some applications of ecosystem service valuation, such as payment for ecosystem services programs. These programs and no net loss policies are gaining popularity, yet their skills are still modest. Finally, we saw that when combining various ecosystem service valuation estimates, there has been a loss in ecosystem services over the past decades. The global economy seems to have grown faster than the loss in ecological service, but as many ecological services have a public goods nature, one can question whether we improved in terms of weak sustainability. This slide contains an overview of the literature used today. Next week in environmental economics, we will explore some of the topics raised in the conclusions by Costanza and colleagues when we explore the desirability of economic growth, alternatives to GDP, and happiness economics. Thank you for your attention. Are there any questions?